Hi everyone, welcome to
amazing channel of Brilliant Qatar.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Qatar.
Good evening, children. I hope you are all ready for the fourth session of our 16 days of challenge. So welcome to Brilliant Qatar live classes. So today we are going to have the session of chemistry and myself Sudhir standing before you. So before starting the session, let me make myself clear with certain points. So when we are going to solve the CBSE MCQ questions, there are few tips to be followed. What are those tips? I am pretty clear with you people that any kind of descriptive questions, you people are able to solve very meticulously and very fantastically. There is no doubt in that. But why do few people get panic while answering MCQs? There are here few tips for that. First point is read the question completely, which we don't do because we are all very confident with our answers. We have gone through the textbook, every page, every paragraph. What is in page number 10? What is in page number 12? What is in 20? What is in 40? When we are confident on that, we normally take it for granted that we are doing the correct type. But there will be certain points where the CBSE will be twisting us, will be screwing up. And to avoid that screwing up, we need to go through the question very carefully. And then what about the options? What are the options given in that? Go through those options also carefully. And then only we will be able to solve the question and give the right option. So in this session, we are going to interact, both of us, along with this chapter, metals and non-metals. Are you ready? I hope you're ready, right? Right, very good. So people are coming. So one more point I would like to tell you, children. While answering or while viewing this video, while viewing this live, make sure that your paper and pencil are with you so that you are able to solve the question and answer in the chat box. I want all the students, whoever is going through the session, a healthy answer and a sportive spirit should be there. Don't bother if it is right or wrong. Right or wrong, if you think your confidence will go down. Let's keep the level of confidence up. Let's not think in a negative way. Let's think always in a positive way and then go through the session. So, shall we start, children, then? So you're ready, right? Let us go for the first question. See, what's the first question? The elements whose oxides can turn phenolphthalein solution pink are. So you must be surprised. Phenolphthalein solution comes in the acids bases chapter. Then why Sudhir is discussing this? Because metal oxides and non-metal oxides we are going through. So let us see whose oxides can turn phenolphthalein into pink. We have already studied that the bases will be converting phenolphthalein to pink, whereas acids or the acidic oxides does not have any action. So let us identify which are the metals which gives bases in their oxide state. Let us analyze what are the metals and non-metals given here. We have few elements like sodium is there with us, then potassium is there with us, then carbon is there, then sodium again, then sulfur, and then potassium, and then phosphorus. So when we go to that, we can identify that sodium is a metal, potassium is a metal, again sodium a metal, and then carbon is a non-metal, sulfur is a non-metal, and phosphorus is non-metal. So what did we say? We have learned that so metal oxides are always basic in nature, whereas the non-metal oxides usually they are acidic in nature. So here we have got sodium, potassium. So these two are the metals for us. Now coming to the options which are given here. Sodium and potassium. So both are metal category. Second option, potassium and carbon. In this, one is metal and the other one is non-metal. One is metal and the other one is non-metal. So definitely we cannot get the combination as the phenolphthalein changing to pink. So we can overrule this answer, this option. Then coming to the third option, sodium and sulfur. Here also we have one non-metal which cannot be considered. So this is also a wrong option. The last one, potassium and phosphorus. Here also we have a combination. So just go through each and every option very carefully. At the end we can come to conclusion that first option, so option A. So here option A, sodium and potassium, which forms metal oxides. These will convert the solution to pink color. I hope I am clear, right, children, all of you? So option is A. So let us see how many have given the right answer. Yes, maximum children has given. Good, good. Keep up, guys. Keep up everything. Very good. Shall we go for the second question? So second question on your screen is here. What's the second question? Which of the following are not ionic compounds? So go through the question very carefully, children. Sometimes they may be asking to identify the ionic compounds. Sometimes they will be asking you to identify which are not ionic compounds. And here they are asking you to identify which is not an ionic compound. And we have studied also that which type of complexes will be giving you an ionic compound and which type of complexes will be giving you a non-ionic compound. Non-ionic compound means it will be a covalent compound. So here, what did we see? We have seen that whenever a metal combines with a non-metal, whenever a metal combines with a non-metal, we will be getting an ionic bond. Whereas, when two non-metals interact with each other, we will be getting a covalent bond. That means a non-ionic bond. So what is this? A metal with a non-metal gives an ionic bond, whereas non-metal to non-metal gives a covalent bond. So let us just go back and find out what is actually an ionic bond. What happens in this ionic bond? A metal is combining with a non-metal. So we have studied in grade 9 that these metals are electropositive in nature. So this metal, based on its electronic configuration, we will be able to decide whether it is a metal or not. We have studied that if an element has the ability to donate electrons, such element is a metal, and an element which has ability to accept electrons is called as a non-metal. So here we have got metals and non-metals. So let us find out which compounds are giving us ionic compounds and which are not giving us ionic compounds. The first one is KCl. What is KCl? Can I get the right answer here? What is KCl? Come on. What is KCl? So KCl is potassium chloride. It is potassium chloride, which is made up of metal is potassium and chloride is a non-metal. So metal and a non-metal. So can we get an ionic bond with this two combination? Yes. So potassium chloride is an ionic bond. Coming to the second option. What second option here? Carbon dioxide, CO2. Here we have carbon along with oxygen, where we have both are non-metals. Both are non-metals. So definitely we are not going to get an ionic compound. So this is not an ionic compound. Then come to the third option. What's the third option? Manganese dioxide, MnO2. Here also manganese is a metal and oxygen again a non-metal. So this is also giving you an ionic bond. Whereas D, what is the last option, children? It is BaBr2. Some children were asking, sir, what is Br and what is Ba? Ba is barium bromide. Barium bromide. Where did we, sir? We never came across such a compound in the textbook, you may be thinking. Barium. So every compound need not be present in the textbook because the relevant ions are already led by us. If you observe the photolytic decomposition reaction, there we came across silver bromide, which contains Br. From there you need to remember what is Br. And in the first chapter, we have studied about the double displacement reaction. There we have studied about the barium sulfate, Ba. So combination of substances, that is called the magic of chemistry. From anywhere they can ask the question. And we need to be ready with our answer. So barium bromide. So barium bromide, BaBr2, where A is a metal and Br is a non-metal. So Ba is a metal and Br is a non-metal. So this is also an ionic bond. This is also an ionic bond. So in this way we have seen all the four, out of which we have seen carbon dioxide. Carbon dioxide alone gives you a non-ionic bond. So what is the right option here? Right option is, yes, very good. Right option is C. Right option is C, 2 only. So in this way, we have to go through the question analytically. Each and every question should be studied. I hope you are enjoying the class, right? Right. Very good. Good. Very good. So now, shall we go for the third question? Right. All of you ready, right? All of you. Rock. Very good. Next question. What happens when iron is heated with steam? Where do you come across this equation, children? Anybody can tell me from where do you come across this equation? Come on, anybody? Safin, Venkat. Yes, come on. So this equation we find out NCERT textbook page number 43, the last equation with the blue color. I hope you are all seeing the question page. So the textbook also along with you, right? Keep the textbook with you and then the pencil and paper with you, because we need to notify these are the important. Whenever I speak some page number means it indicates that that particular equation is pretty important. So note down that, children. Don't miss that question while you are revising your board exams, right? Okay, children. Okay, right. So what happens when iron is heated with steam? So this reaction comes under action of metals with water. What is it? Action of metals with water. Action of metals with water. So this action of metals takes place in two steps. Takes place in two steps. Step 1 and step 2. You're all putting the answers right? All of you? Right. See. Good. Yes. The answer is Fe3O4. Let us see how this answer comes. So two steps as I have discussed with you. What is the first step? Remember always, children. Remember the concept. So metals, the reacting metals. When we are telling metals, we cannot include all the metals because there are few metals which are non-reactive also due to their low reactivity. So the reacting metals, when they are treated with water, when they are treated with H2O, they form their respective metallic oxides. Whatever the reacting metal you take, whatever the reacting metal, maybe it is a high reactive metal or a moderate reactive metal, these metals, when they are treated with water, in any condition, again, water has got various conditions. Sometimes it is a cold condition, sometimes it is a warm condition, sometimes it is very hot condition, bubbling, and sometimes it is a steam condition. Whatever it is, every reacting metal will be forming a respective metal oxide. Then what's the second step? So these metal oxides continue their reaction with water to form respective metal hydroxides. Why am I mentioning X and Y? Because their bases might be varying. 1, 2, 3, 4 it may be. So MX, OX. So metal hydroxides are formed in the second step. So this is the sequence of the reaction of metals with water. But what is the product formed here? Fe3O4. According to the steps, it should be hydroxide. But what is happening here? Remember, children, here there are two categories of metals we have already discussed. One is high and one is moderate. Are you able to follow, all of you, me? Right. Okay. So now, these particular high reactive metals, they will be undergoing both step 1 and step 2. Sodium, potassium, magnesium, calcium. These four metals, remember all of you children, sodium, potassium, magnesium, calcium. These four metals will be giving you, default you can remember, hydroxides. The next category, so-called the moderate reactive metals, like aluminium, zinc, iron, lead, manganese. What are those? As per your syllabus, there are few more, 1 or 2, but it is not concerned with us. So what we are concerned? Aluminium, then zinc, then iron, then manganese and lead. These 5 metals will be stopping near the step 1. That means they end up their reaction with oxides. They end up their reaction with oxides. So it is clear that iron is a metal which is moderate reactive, and this iron will be giving you an oxide. Now, what are the oxides present with us? So iron has got 2 valencies. One is +2 and one is +3, right? So if it is +2, what is the oxide formed? And if it is +3, what is the oxide formed? So if it is +2, iron, if it is +2, it forms FeO, and if it is plus 3, it forms Fe2O3. Can anybody tell me what is the color of Fe2O3? Anybody? Fe2O3. Yes. Fe2O3, it is reddish brown in color. It is also chemically called as rust. So ferric oxide. So here, when Fe is treated with steam, as per the calculations with us, it must form either FeO or Fe2O3 because Fe exists only in 2 valencies. But from where this third option is coming, from where this Fe3O4 is coming, what oxidation state does it speak about? What charge is it saying about? Because Fe existing only in plus 2 or plus 3. Remember children, this is a very important point. Fe, when treated with water in steam, in gaseous state, forms Fe3O4 along with hydrogen gas. This Fe3O4, remember children, all of you, please make a point. Fe3O4 is called iron oxide. It has no chemical name because it is not a chemical compound. It is a mixture of FeO and Fe2O3. Am I clear to all of you? It is a mixture of FeO and Fe2O3. So calculate there, 1 Fe and 2 Fes, 3 Fes, and 1 plus 3, 4 oxygens, Fe3O4. So Fe3O4 is not a compound, but it is a mixture, Fe3O4. Am I clear, all of you? This is called iron oxide, and this is formed when iron is reacting with steam. Reacting with steam. Am I clear, all of you children? Any doubts? Yes, Fe2O3 is rust, ferric oxide. Very good children. Good. Yes, magnetic iron oxide. Very fantastic. Good. I want everybody to answer. I'll be just asking my crew. So how many people are answering? They'll be giving me a count. And I wanted to see how many are participating and how many are actually active in answering. And one more point, children. You people are from Brilliant. So you are getting the link and you are viewing this concept. What about your dear ones who have not? So what to do? Immediately take your mobile, share the link with your dear ones and let them also get benefited to these MCQs. Because at the end we are all one. So we should be supporting each other. Let us let us share the link to all our friends and relatives so that anybody who is in need may get benefited. And tomorrow they'll be giving blessings. Oh, this guy has sent me the link and I have got the questions. So don't delay, share the link and let everybody get benefited from our classes. Okay? Right, children? So again, come back. Let us go for the next question. Next question, which of the following statements are incorrect? The options are before you. What's the first option? Read, children. See, certain questions are according to the CBSE only, but little bit tricky and twisty. Try to analyze that situation. Okay? What are the options? Option 1, reactivity of aluminum decreases if it is dipped in nitric acid. Read the option carefully. Second one, carbon can reduce the oxides of sodium and magnesium. Third one, NaCl is a good conductor of electricity in solid state. Fourth one, metals like potassium, calcium, and magnesium are always found in free state in nature. These are the 4 options before you. And you need to select the right answer. So options are with you, right answer you want to select. So there are no here lifelines for you. Only lifeline is you and your brain. So use that lifeline and solve this question. Let me see how many of you are able to give the right answer. Yes. Good. Very good. But I'm seeing the answers always the same people only. Why not the other people? There are many people who are participating in the live, but only few people are giving me answer. I want everybody. Yes, yes, yes. Yeah, 97 students are live. 97 students are live. But how many are commenting? We can see very few people commenting. Come on, children. Come on. All questions are from your textbook only. Come on. Now, yes, answer is option D. Whether it is right or not, let us see. Maximum people are giving answer. Let us analyze situation. First one. Let us go from the bottom onwards. What's the fourth option? Metals like potassium, calcium, magnesium are always found in free state in nature. Right or wrong? Metals are highly reactive, so how can they stay in the free state? They never stay. The free state elements are least reactive, platinum, palladium, but not sodium and potassium. So that is the incorrect statement. Mark it X. Right. Come to the third option. NaCl, ionic compound. And we should remember that in the second chapter, we have studied a bulb experiment activity. Do you remember? Right. You people remember very well. Good. So there were 3 bulbs where one was having a molten salt, which is in a liquid state, and one is a dry compound. So in that experiment, we have studied that any salt in dry state does not conduct electricity. There is no conductivity at all in a dry state. So what is given here? NaCl is a good conductor of electricity in solid state, which is absolutely wrong. So strike off. Third option, carbon. Carbon can reduce oxides of sodium and magnesium. Is it the right option? We studied that sodium and magnesium has got high affinities. They will not leave oxygen for the sake of carbon for undergo displacement. So that option is also locked wrong. So what is the first option left over? Reactivity of aluminum decreases if it is treated or dipped with nitric acid. Is this right or wrong option? Some people will be having a doubt. With that doubt only, they are still surviving. Let me clarify. Aluminum reactivity decreases when it is with nitric acid. Why? What is the reason? You all know that there are few metals like magnesium and aluminum. These metals, when they are exposed to air, they undergo oxidation. They form an oxide layer around that, right? That is one factor. And second thing, what is the role of nitric acid here? Nitric acid is a strong oxidizing agent. So this oxidizing agent work is what? It has to supply oxygen. So this particular aluminum, it takes this oxygen initially and gets converted into aluminum oxide. And once the layer is formed, the reactivity reduced. It came down. That means what? Reactivity is not, it undergoes, it takes place, but slowly decreases. Not like the other metals which are actively participating in a chemical reaction. Here we can see some children also like aluminum who are slowly only listening, spectators. We want active participation like sodium, potassium, calcium. So here aluminum decreases its reactivity because of nitric acid, its oxidizing agent. So that is the right statement. So what do we need here to select? The incorrect one. So B's, that means 2, 3, 4 are the wrong options and the right option is option D. So congrats for the people who have, yes, now it has come to 110. Yes, 110 participants are there in the live. Come on, children, rock. Still, you can like, but don't forget to like the video, okay? Like the video and then subscribe. See, there are few children who are not in our brilliant, but still they are viewing the classes. And you people cannot get the link immediately. You need to depend on your classmates. So if you subscribe, what will happen? These videos will come directly. The links will come directly into your inbox. So you can get blessed with that. So let us go with the next question. Right. Fe2O3 plus 3C gives rise to Fe plus 3CO. So here, what type of reaction is it? What type of reaction is it? Can I call it as a redox reaction or not? I need the answer also. Yes. So it is a redox reaction. So let us see what is happening with this. Fe2O3 plus 3C gives rise to Fe plus CO. In this reaction, C acts as dash. What is the action of C? C refers to carbon. So I will tell you one tip how to solve these redox reactions very, very easily. See children, all of you, let me take this reaction. Fe2O3 plus C. I'm not balancing it, okay? I'm just in the blank equation. Gives rise to Fe plus CO. Okay, for your condition, for your convenience, let me put the numbers also. 4 Fe and 3 CO. Now, what is the process happening? What is the change happening here? Observe carefully, children. Observe very carefully. Fe2O3 is getting converted to Fe and C is getting converted to CO. So here what can we say? Carbon is converted to carbon monoxide and iron oxide is getting converted to iron. So what is observed here? Here what we observe is carbon is gaining oxygen and here next iron oxide is losing oxygen. And we know that gaining of oxygen is called oxidation. Gaining of oxygen is called oxidation and loss of oxygen is called reduction. Loss of oxygen is called reduction. And here, what I said for you, I'll be telling you a tip, right? Remember children, all of you, there is one point here. Substance oxidized and substance reduced. Substance oxidized and substance reduced. In exam, they'll be asking only 4 points in this. Identify the substance oxidized, identify the substance reduced, which is the oxidizing agent and which is the reducing agent. Remember here, these two pairs are crisscrossing with each other. A substance which is getting oxidized is a reducing agent. Don't forget this, children. Always in this regarding, substance oxidized is equal to reducing agent. And similarly, a substance reduced remains as oxidizing agent. This is one way we can analyze. And still more, your exam board paper, I am keeping in view only the board exam paper and I am telling you children, most of the redox reactions will be having oxygen definitely in the question paper, like this. In this situation, Fe2O3 contains oxygen, right? Yes, Fe2O3 contains oxygen. So treat it as oxidizing agent. Class, finished. The work is done. So let me come to conclusion. Fe2O3, I hope you can see my writing right. Fe2O3 contains oxygen. So it is oxidizing agent. Whereas the other one, carbon, contains, it is called reducing agent. So Fe2O3 is oxidizing agent which contains oxygen. We know who is a ticket man. So who has ticket is called ticketing agent. Who supplies tickets is called ticketing agent. Like that only we have seen here, which supplies you oxygen, oxidizing agent. So the other one is reducing agent. So what do you say? Whichever is oxidizing agent is also substance reduced. That means Fe2O3 gets reduced. Fe2O3 gets reduced and it is an oxidizing agent. Similarly, carbon Carbon is reducing agent as well as substance oxidation. This formula, if you follow the question, you need not break your heads. You need not start thinking. Because MCQ questions, you should have less time to spend. So here, carbon acts as, what is it here? Carbon is a reducing agent, option B. Reducing agent, option B. This is the way how to solve a question. Most of you are solving it, but there are few people who are not solving. For those people, this will be as an tip to solve, to identify oxidizing agent or reducing agent. Substance oxidized or substance reduced. Am I clear, children? Right. Let me go for the next question. See here, a big question. Looking at the big question, we are scared. Oh my goodness. So big question. Let us skip. Let us go for the last. Let us keep it for the last. No. Even the question will be big. You need not worry. Questions will be bigger like dinosaurs. But there are few dinosaurs which are vegetative, which are herbivorous. So treat the question like that. A very simple question. Brief information given about few elements. P, used in making electrodes. We need to analyze it. We don't read the question and we skip it. Read the question better, first of all. It is used in making electrodes. That means conducts electricity. Which element conducts electricity? Here all are given for as options. Second one, it is required for combustion. It is required for combustion. Third one, used to preserve food. Preserve food means, I will give a hint here. Preserve food means here, elements are there. Which element is preserving food, sir, for us? Immediately our thought must go towards the topic of rancidity. Rancidity. Page number 13, NCERT textbook, rancidity and corrosion. There you will get it. After redox reactions. Redox reactions, page number 12. The other side, on the right side of the textbook, you can see rancidity and corrosion there. Preserving food. Fourth one is fungicide. So which is the right option here? Which is the element used in making electrodes? Electrodes, commonly, he didn't mention any specific. So commonly electrodes means we take graphite. Graphite. Electrodes. Metal electrodes are different again. We are talking about a general electrode. Common electrode means graphite. Anode. Graphite. Graphite is nothing but an allotrope of carbon. Graphite is allotrope of carbon. Next one. Q. Required for combustion. Required for combustion is, what is that combustion? Which can burn a substance. It requires oxygen. It requires oxygen. And then, next one, which is used to preserve food materials for rancidity, which avoids rancid. Storing food, preserving food materials. This is nitrogen. And the fourth one, used as fungicide. Which is the one which is a fungicide? Yes, sulfur. It is sulfur. So which is the combination which gives all the four? Carbon, oxygen, nitrogen and sulfur. It is option 4. Clear all of you? This is the, see, so simple question. But what we do, we get scared looking at the big paragraph. Right? Coming to the next question, all of you, on your screens. Which of the following reacts with dilute nitric acid? Page number 44. Page number 44. Second paragraph, second line says about the reactivity of metals with nitric acid. 44 page number, second paragraph. Go through all of you. You will get it immediately information. Most of you also know it. But again, still, I'm reminding you. Because it is very important equation. Reaction with nitric acid. What happens with the nitric acid? Each and every acid, when you take normally reacting acids with metals, gives hydrogen gas. But this nitric acid, a special feature of oxidizing agent. it will oxidize the hydrogen formed into water and releases oxides of nitrogen. Sometimes it gives nitric oxide, sometimes it gives nitrous oxide, sometimes it gives nitrogen dioxide in this way. Different types of oxides basing on its convenience. It is like a chameleon. Sometimes it gives, if the metal is feasible, nitrogen dioxide. If not feasible, nitric oxide. Otherwise, nitrous. So many types of oxides. That is not our question now. The point is, which of the following reacts with nitric acid? What is the answer here? Yes, here I can see some dual answers. Some are giving A, some are giving C, some are giving A, some are giving C. Come on, come on, come on. Meanwhile, I will have just a sip of water. Okay? Yes, yes, yes. A, B, A, B, A, B. Right. A, B, A, B, A, B. Reacts with nitric acid. Reacts with nitric acid. Come on, Safin, Void, I don't know. Anil, Utkarsh, Atmana, Arsh. Yes, Mrugala, Karthik. Come on, come on, come on. Good, good, good. Night. Shall we go now? Yes. The answer is D. Surprising, right? A twist in the question. This is the way how we lose our 1 mark in our board exams. I told you previously also in the classes while I was dealing. Your 1 mark is in the hand of chemistry, my dear children. Because you will be panicked under certain conditions. Let me clarify it with you. We all say that copper and silver we ignore from our mind. Because copper are low reactive. But don't forget that the opponent is nitric acid. So what happens here? Copper and silver. So copper if you take, I am not going about sodium magnesium because sodium magnesium already you know it because it is a high reactive metal. So let us come to copper, which is a low reactive metal, which does not react with other acids. But nitric acid, strong oxidizing agent. So it will motivate the reaction to occur. So it gives copper plus nitric acid gives rise to normally copper nitrate, right? Yes, it gives CuNO3 twice plus so it gives back nitric oxide plus water. So copper plus nitric acid gives rise to copper nitrate plus nitric oxide plus water. Okay, next one. If you take the case of aluminum, so silver, what is silver giving for you? Silver also reacts with nitric acid. Silver also reacts with nitric acid. So to form here also, so silver AgNO3 plus O plus water. So here silver reacts with nitric acid and copper reacts with nitric acid. So in these two situations, copper and also silver reacts with nitric acid to form various compounds. Am I clear, children? So reactivity is feasible with the copper and silver. So option is all the above. All the above. Clear all of you? So nitric acid makes the reaction to occur in the case of copper and silver. It gives oxides of nitrogen along with the sodium and magnesium. So answer is all the above. So magnesium always forms magnesium nitrate plus hydrogen. Sodium forms sodium nitrate plus water molecules. Let us go for the next question. Yes. Copper reacts with air to form. Here, whenever we say air, is it only air? It involves air, moisture, everything present inside. So what happens copper with air? In the topic of corrosion, we study about 3 metals. What are those 3 metals? One is copper, one is silver, and one is iron. These 3 metal corrosion we have studied. And they have given their own results. So out of that, we are discussing about copper. What is the answer here? Copper in air. Sometimes, listen children, regarding copper, they will be giving you 2 questions with the air only. Copper with air have 2 types of questions. Copper when heated with air, copper when treated with air. Treated means in the presence of air. Copper in the presence of air, what is going to happen? Copper in the presence of air when heated, what happens? Let us see here. So copper, what is the right answer here? Let me see how many are giving it. Yes. It is basic copper carbonate. Option C is basic copper carbonate. So what is the reaction? Let us see. Copper reacts with carbon dioxide, oxygen and water, moisture, to form CuCO3 dot CuOH twice. CuCO3 dot CuOH twice. This is called basic copper carbonate because it is basic in nature. This is called as excuse me, basic copper carbonate. Can anybody tell me what is the color of copper carbonate? Let me see how many will you answer this question. What is the color of copper carbonate? Come on. Copper carbonate. What is the color? Come on. I hope the buffering is taking time for us to get the results. People are typing there, but it is taking a bit of lag for me. Okay. Not an issue. Right. Oh, yes. Muttu Priyadarshan Saravanan. Good. Crazy Gamers. Oh, good. Safin. Good. Fatih Green. Yes. It is right. So, it is green color. You must have observed. Normally, when we go for vacation at home, we'll be seeing our things all or will be here and there. And in that, if you see a green, that means color on a copper utensils, glasses and all, etc., we can see a brown patch, brown coloration around. That brown coloration, nothing but copper carbonate, along with the white spots. That white spot is called copper hydroxide. And the green color is due to copper carbonate. Copper carbonate, right. So this particular copper carbonate is formed when copper treated with air, children. Whereas what happens if copper is heated? Copper heated, what it will give you? Copper plus oxygen on heating gives rise black colored copper oxide. I could see some children are making it as giving the answer black. But that black is formed in copper oxide situation. When it is heated, when it is not heated, when you just leave it on itself, it is giving you greenish white. Green is copper carbonate and white spots is copper. Whereas if you heat the copper, it will give you black colored. It gives you black colored copper oxide. Am I clear, children? This question should be always kept in mind. They will give it as like this, okay. A brown shiny metal, when heated in the presence of air, gives us a black residue. Black residue, which on treated with hydrogen, again gives the metal back. That is redox reaction. Cu plus O2, CuO plus hydrogen again gives you copper back. So in this way, you need to solve the question very meticulously. Okay, children? Right. Let us go for the next. Thank you. Right. Rock. Come on, quick. Next question. How is copper oxide generally reduced to obtain copper, crude copper? This is again important question in the topic of metals and non-metals, extraction of metal topic. Extraction of metals, especially the low reactive metals. These low reactive metals, what is it going to do? Copper and mercury we are studying here. Am I right? Copper and mercury we have studied in that. How this copper is getting reduced? Now, copper oxide is getting reduced. What is the answer here? Wow, wow, nice, nice. Thank you. Yes. A D A D A D. Think. Fatih, think. Abdul Wadud, think it. Yes. Right. So shall we disclose the answer? If there's any chance, you can change your options also. All of you perfect now? Shall we lock it? Sharmila, Anil, shall we lock the answer? Yes. You lock your answer at your point. Yes. Good. Yes. Now, answer is option C. By using copper sulfide. Can anybody tell me what is the process named as? By the time I finish off the explanation, I have to see the phenomenon which we are going to opt with this copper sulfide in the chat box. Let me see how many are going to give the phenomenon. What is it known as? The reaction of copper oxide with copper sulfide. Cu2O plus Cu2S gives rise to Cu plus SO2. This is the crude metal. This is the crude metal which we are obtained from the oxide. The oxide, here what we do before this, we go for roasting. Low reactive metals are in sulfide form. Low reactive metals are available in sulfide form, and those sulfide forms we go for roasting. So that roasting, when we go in the presence of air, we get it respective oxide, and that oxide we are going to reduce using copper sulfide. What do you call it as? Come on, few. Yes, Mridul Abin, very good. And Venkat Anil, it is called self-reduction. What is it called as? Self-reduction. Here the ore is taking an active part. The oxide which you are formed, the oxide which you are getting, we are treating it with the ore itself, the crushed ore itself. When we use that crushed ore with that oxide, it gets self-reduced. The oxide gets reduced to copper and releases sulfur dioxide gas. These sulfur dioxide gases are identified with a burning sulfur smell. So in this way, this process we call it as self-reduction. Very good, children, very good. Whoever goes through the NCERT textbook page to page, para to para, line to line, will be able to answer these questions. And I said, these are the questions which are going to trouble you in exam. Normal questions everybody can answer. Who is the hero? Who solves such kind of questions? Everybody will play cricket. But who will notified? Who will be hitting 6 upon 6 will be only notified. Like that only such a kind of difficulty questions, if you are able to solve, then only you are called as the heroes of the nation. Come on, quick. Next question. Next one. What happens when zinc is treated with NaOH? What happens? This is one more question, important question. This is easy question. Everybody will know the answer. But most of us will make a mistake. I have given here words, so you'll be able to answer it. What, suppose if I give it as a formula, there is a chance of committing a mistake. So I don't want it to confuse you much, so I've given a simple question. But in the next session when I come, I will be coming out with the hots. So get prepared for that for the next session also. So what happens when zinc with sodium hydroxide? So what is the role of zinc here? Don't forget, there are two metals, aluminium and zinc. These two metal oxides are amphoteric in nature. We studied that. We have studied in acid bases also. Aluminium and zinc. These two oxides are amphoteric in nature. And what is the meaning of amphoteric? Which reacts with both acid as well as a base. Both are here showing the reaction. So, certain times it acts as a base, certain times it acts as an acid in the presence of acid and base. So here he is asking to treat zinc with a base. So zinc with base forms, what is the option? Yes, see. Can anybody tell me the formula of this sodium zincate? Anybody can just again put the formula. Sodium zincate gives, I will write the name. Let me get the formula from my students here. Sodium zincate along with hydrogen. Yes, Safin Parker, the first one. Na2ZnO2. Very good, beta. Very good. Rock. Safin Parker. So he got the answer first. Na2ZnO2. Yes. Good, 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 good. So sodium zincate, Na2ZnO2. Similarly, when we take aluminium, Al plus NaOH. Come on, what is this formula? So come on the chat box. What is the formula for sodium aluminate? Forms sodium aluminate. What is its formula along with hydrogen gas? Come on. What is the formula for? Okay, Mrudal, good, good, good. Maybe I have missed up you. No problem. So you are the first. Very good, beta, very good. So, what is the formula for sodium aluminate? Come on, come on, come on. Yes, again, Muhammad Arsh. NaAlO2. Very good, beta, very good. NaAlO2. Sodium aluminate. And for zinc, it is sodium zincate. So, these reactions should not be forgotten, children. If it is a metal, you get hydrogen. Suppose if it is an oxide, you get water. But the reaction remains the same to same. Metal plus NaOH. It gives zincate or aluminate along with hydrogen. If it is metal oxide, you get water molecule. So this is the only difference which will come across. Okay? Remember these tips, children. Remember these questions, children. These points are very, very important for the board examination. Generally, you will be going through, you will mug up sometimes, you will go through like anything, but the crucial parts and the sensitive parts we forget. So these points, make an underline or note in a paper, the page numbers and the equations, don't miss during exam revision. With that spirit, let us go for the next question on your screens. The following pairs of substances are present in the laboratory. Okay? There are few substances combinations. What are those? Zinc and HCl, nice. Zinc and NaOH, oh, very nice. Next, NaOH and HCl, okay. And NaHCO3 and HCl, okay. So, what is the question? Which of the following pairs can be used to produce a colorless and a odorless gas, which gives a pop sound? As soon as you listen a pop sound, what should come into your mind? Right, it is none other than hydrogen. When you listen the word pop sound, when you come across the word pop sound, the immediate word should come into your mind is hydrogen gas. That means one of these pairs should give you hydrogen gas. Let us see what is that option. What are those options? First one, zinc with HCl. Zinc with HCl. It gives zinc chloride plus hydrogen. Second option. So can I tick the first one? With your permission, children? Right. So it has given us hydrogen because it is converted in the pop sound. Next one. Second one is what? Zinc with NaOH. Just now we have seen. Zinc with NaOH. It also gives us, what is it? Na2, ZnO2 plus hydrogen. So this is also right option, my dear. Oh my God. We have got two options already. Let us see. Next what? NaOH plus HCl. NaOH plus HCl. What do you get here? We get here H2O and NaCl. Neutralization reaction. So this is not giving you hydrogen. So Khalli will strike off. What is the fourth option? NaHCO3 plus HCl. I just wanted to focus on this equation. What is the product formed? And what type of reaction is it? NaHCO3 plus HCl normally should give you, because it contains a plus and minus, it also contains a plus and minus. So normally it should give you a double displacement reaction with two products, NaCl and H2CO3. Listen carefully, children. So here also we don't get any hydrogen gas. So this is also a wrong option. Let me come back to this point here. So keep this point carefully in your pocket. Okay, don't release this out. This fourth point I'm going to discuss after the answer. So basing on these four equations, we have come to a conclusion that only 1 and 2 gives you option. So automatically the answer stays with option 4. Good, good. Many people liked. So I'm running short of the time. I hope. See, my people are already giving me an alert. Sir, please try to wind up. Okay, right, children, I'm going to wind up with the last point of NaCl and H2CO3. Listen, children, here. As per the records for us, everywhere in the you can see that when a metal carbonate reads with an acid, it gives us salt, water, and carbon dioxide. But why did Sudhir Singh has given you H2CO3? Is he wrong? Definitely not. This is actually formed. H2CO3 is actually formed. But what happens? Do you know that H2CO3, carbonic acid, is a weak acid? And this weak acid cannot sustain for a longer time. And immediately it decomposes into H2O and CO2. It decomposes into, let me change the color. It decomposes into H2O and CO2. That's why we write it as, if you observe page number 20, the last equation, Na2CO3 plus HCl or NaHCO3 plus HCl gives you NaCl plus H2O plus CO2. So that is the reason. Normally it is a weak acid and it decomposes into H2O and CO2. It is a double displacement reaction as well as a neutralization reaction, because NaHCO3 is a basic salt, HCl an acid, so neutralization definitely takes place and gives rise to formation of NaCl, a neutral salt. Am I clear to all of you? So that's the end of the day. I hope you're all enjoying the class. So very few questions we finished, but in the next class I will be coming out with a few more heart-throbbing questions and also some things which are to be using your brain really, so that you can rock the floor during your CBSE exams. Okay, children, I hope you must have liked the video. So wait, stay tuned, don't go back. We will be shortly back with our biology class. Okay, children? So take a break, have some water, take some biscuits, but don't go away. Join us. Okay? The link is already sent with you with a separate link. Join that link and enjoy the class of biology, the life sciences. Okay, children? Thank you and good night. Have a fine sleep. And don't be tensed when we are here with you. The brilliant team is with you, so don't be tensed. We will be solving your questions and we will be taking your trouble. Okay? Stay tuned. Thank you, children. Bye-bye.
Hi everyone. Welcome to
Amazing channel of Brilliant Qatar.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartless fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
water.